Circle theorems. In this recording, we are going to look at a mixture of circle theorem questions. I've got this worksheet from Maths Genie, and it starts from easy and gets more complicated. Here are all your circle theorems. Yes, there are 8. I've added in 1, not a theorem. I'm just going to put isosceles triangle by here. This is where we mark off the radii. And it form, and we can see it's an isosceles triangle. Print screen this, maybe print it off. Have a look at it next to the questions you're doing. Okay, your first decision to make with these is, does it have a tangent or does it not? Is it a tangent theorem? Question 1 does have a tangent. So often you see the tangents going a bit kind of longer than this, but this isn't. It does have a tangent. So we know we're looking at the tangent theorems. So which tangent theorem is it? Can you see we have a circle, we have a radius touching a tangent, so it's number 6. The angle between a radius and a tangent is 90 degrees. I'm just going to leave that over there so I can refer back to it. You must show all your working out. Okay, so how are we going to get the angle BAO? BAO is this one here. So BAO equals 180 minus 90 minus 72. So that's what it means by showing you working out. $18 degrees. Okay, question 2. A, B, C, and D are points on the circumference of the circle. BOC is 66. We want to work out the angle BAC. We haven't got a diameter. Have we got an arrow? Yes, we have. So the angle at the circumference is half the angle at the centre. So BAC is 33 degrees. And the reason is the angle at the circumference is half the angle at the centre. So if asked for a reason, you have to actually quote the circle theorem. You see how that's a bit different than showing you working out. I missed a little E off there. Oops. Okay, for question 3, I've got the tangent theorems up because we have 2 tangents. B and C are points on a circle, centre 0. AB and AC are tangents to the circle. BAC is 40 degrees. Let's get that one in. Work out the size of angle BOC. So let's join B to O to C. And let's just see for the tangents theorem 6, we do have a right angle, but I'm just going to join these together as well. No, in fact, let's just use circle theorem 6. So we've got a right angle because we have the angle between a radius and a tangent. Same here. Angles in a quadrilateral add to 360. So 360 minus 40 minus 90 minus 90 gives us the angle BOC, which is 140 degrees. If you have a look at these next 3 questions, maybe you'd like to have a go yourself first, put me on pause and unpause when you complete it. Now, all 3 of these are there's no tangents, so they've all got to be non-tangent theorems. So question 4, find the size of ACB. So ACB is that one. Give a reason for your answer. Okay, so ACB, we've got our bow. So it's 51 degrees because these two at the bottom are the same. And your reason is angles in the same segment are equal. Question 5. Well, there's no diameter, so it's not 1. There's no arrow or arrow in disguise, it's not 2. There's no bow shape, not 3, but we do have a quadrilateral. Opposite angles add to 180. We need ABC, so it's that one. They add up to 180. So ABC is 97. And your reason is opposite angles in a cyclic quadrilateral add to 180. And question 6. You want AOB? Okay. We haven't got a diameter, not 1. There's no arrow, not 2. No bow, not 3. No quadrilateral. This is not a theorem. We've got our isosceles triangle. Find AOB, give a reason for your answer. So we can write AOB is isosceles. So OAB is 48 degrees. Angles in a triangle add to 180. So 180 take away 2 lots of 48 is 84. Okay, for 7 and 8, we do have our tangents. So for question 7, can you see we need theorem 8? Got an isosceles triangle. Got to give a reason for each stage of our working out as well. So let's just get rid of that here now. So this is an isosceles triangle. These angles are the same. So we can say BAC equals, so 180, take away 46, divided by 2, 67. What angle are we actually looking for here now? OAC. So we're looking for OAC, this angle here. So what's our reason? Let's go back to our theorems. You do need to know these. Tangents to a circle from the same point will be equal length. Okay, and then we have a radius touching a tangent. So now that's theorem 6. Angle between a radius and tangent is 90 degrees. So we can say OAC. Well, in fact, no, let's say OAB. Not sure if I used the right word in there, but angle between a radius and tangent. Okay, same idea. And then OAC is 90, take away 67, which is 23. Okay, so we've got A and B are points on the circumference of a circle, centre O. DCE is a tangent to the circle. ACD equals 76 degrees. Find the size of the angle ACO. So we know that OCD is equal to 90 degrees. And why? Because it's an angle between a radius and a tangent is 90. So to get that angle there, we know the whole thing's 90. 90 minus 76 gives us our missing angle, which is 14 degrees. So ACO, 14 degrees. Part B, find the size of the angle ABC. So can you see? Oh, let's get the tangent theorems up. Well, we have actually got them up here. So can you see we've got the alternate segment theorem here? You've got a tangent touching the triangle here, ACB. So the opposite angle is 76 degrees. So ABC is 76 degrees. And your reason is the alternate segment theorem. Okay, we should notice these questions starting to get more complicated now. Okay, so A, B, and C are points on the circumference of a circle. B, D, and C, D are tangents. So already I'm just going to note we've got a radius, so 90 degrees, 90 degrees. Because of my theorem number 6, angle between a radius and a tangent is 90 degrees. Angle ODC, 26 degrees. Find the angle BAC. Give a reason for each stage we're working out. So B, A, C. This is the angle we need. Just because we put them in as 90 already, I'm just going to put OBD equals 90 degrees. And the reason is the angle between a radius and tangent is 90. Okay, so I've used my tangent theorems. I've got my non-tangent theorems here. But is there anything I can work out here? Well, I can work out that COD, angles in a triangle, add up to 180. So 180, take away 26, take away 90 is 64. I might actually write that as my reason here as well. So angles in a triangle add to 180. Okay. We also know, don't we, that from our tangent theorems, I'll just bring those over. We know that number 8, the tangents to a circle for the same point will be equal length. So can you see we've actually got a symmetrical shape here, haven't we? So this is 64 as well. And here we've got 26. So we can see BOC is equal to 128 degrees. Now, hopefully you've spotted we've got a arrow here. We've got an angle at the centre and the angle at the circumference. So BAC is equal to 64 degrees because the angle at the circumference is half the angle at the diameter. The centre. Did I say diameter? The angle at the centre is half the angle at the centre. There we go. Number 10. A and C are points on the circumference of a circle. BC is a tangent. I feel like I want to join this here. Because if I join that there, we got 90 degrees. Don't need our reasons, just need our work in here. So OCB is 90 because we've got tangent, an angle between a tangent and a radius. But what else? What do we even need to find? ABC. There we go, that one. Okay, let's look at our non-tangent theorems now. Right, we have one. It's not one. We haven't got a diameter. There's no arrow. It's not 2. There's no bow. It's not 3. There's no cyclic quad. It's not 4. Have we got not a theorem here? Well, we've got a radius and we've got a radius. So we have an isosceles triangle. So this one here is 29 degrees. That's OCA. And then we have angles in a triangle add to 180 because this entire angle there is 90 plus 29. Haven't drawn that in very well, but anyway, it's 119. So ABC is 180 minus 119 minus 29. 32. Oh, we've got some tangents here. Let's get my tangent. Right. ABC is 61. ACB 73. BCE is X. I can see immediately here we have the alternate segment theorem. So this angle here is the same as the angle opposite. So here, so that one is the same as X. Okay, what is X? Well, or what is that angle rather? We have a triangle. Angles in a triangle add up to 180. So BAC equals 2. 180, take away 61, take away 73, 46. And my reason there is angles in a triangle add to 180. So then we can say X is equal to 46. And our reason is simply alternate segment theorem. Okay, AOC. We should join it together first. Got a tangent here. Have we got a tangent touching a radius? Well, yes, we have actually. That's 90. So we can say that OCB is 90 minus 65, which is 25. We've also got the alternate segment theorem. Got a lot going on here. Can we see that angle touches the triangle ABC? So, sorry, the tangent, the angle that's made from the tangent touching that length is the same as CAB, that one. That's 65 degrees. So we can say BAC is 65 degrees. Okay, so now I'm just being drawn into this isosceles triangle here. So an isosceles triangle, these two angles are the same. So this full angle on the bottom here is also 65 degrees. Angles in a triangle, hang on, let me write that down first. So BCD is equal to 65 degrees. So ABC is 180, take away 65, take away 65, which is 50. And then also, I don't know if anybody's spotted the arrow here. You've got angle at the circumference and angle at the centre. So angle AOC is double ABC. So it's 2 times 50 degrees is 100 degrees. Question 13. Okay, so for question 13, we'll look at our non-tangent theorems. Question 1, do we have a diameter? No. 2, do we have an arrow? Yes, we do. So we know the angle at the centre is double the angle at the circumference. We don't know either yet though. 3, we don't have a bow. Do we have a cyclic quad? Yes, we do. So opposite angles add up to 180. Doesn't ask for a reason, but asks for the working out. So ABC is 180 minus 118, which is 62. And the angle at the centre is double the angle at the circumference. So AOC is double 62, so 124 degrees. Right, we do have tangent theorems here, which I'm going to look at first. So we've got a radius and a tangent. So the angle between a radius and a tangent is 90 degrees. So we need a reason OCE equals 90 degrees. And your reason is the angle between the radius and tangent is 90, which means that OCB is 90 take away 53. So we're looking at this angle here, 37. We want ACO, that's the angle we're looking for there. Right, we have got a isosceles triangle here. We've got not a theorem, got a radius and a radius. So that's 37. So CBO equals 37. And your reason is isosceles triangle. Okay, then we have the angle in a triangle add to 180. So COB is equal to 180, take away 37, take away 37, 106. Then, if you spotted your arrow, number 2, you can see that CAB, hang on, let's just put that in as 106. CAB, the angle at the circumference is half the angle at the centre, so it's 53. And then my reason is angle at the circumference is half the angle at the centre. And just put that on the diagram. We also know angles around a point add to 360. So the angle, the reflex angle COB is 360 minus 106, so 254. I feel like there's probably a different way you might have done this one. And then we've got angles in a quad add to 360. So ACO is 360 minus 254 minus 53 minus 27, which is 26. (15 and 16). A and B is a point on the circumference of a circle. AC is the tangent. OBC is a straight line. So we've got 90 degrees. We know OAC is 90 degrees, right? Because we've got a tangent on a radius. Now we've actually got lengths here, haven't we? We want the length BC. We know we've got a right angle triangle OAC, right? So we're going to take that out here. We've got a right angle triangle OAC. So can you see it's Pythagoras to get the length OC? So A, B, and C. C is your hypotenuse. A squared plus B squared is equal to C squared. So we've got 5 squared, not 15, it's 12. So we've got 5 squared plus 12 squared equals x squared. Square and add, we get 169 is equal to x squared. Square root both sides, x is 13. So the whole length from AC is 13. We actually know OB is 5. So BC, the whole thing is 13, right? So to get BC, 13 take away 5 is 8. So BC is equal to 8. Okay, question 16. ABC are points on the circumference of a circle. CAB is 2x, ABC is 3x, find x, right? So we've got a diameter and a triangle, so we've got 90 degrees. I know that angles in a triangle add up to 180 degrees, so let's form an equation. Simplify. Subtract 90 from both sides. Divide both sides by 5. Gives us x is 18. Okay, last 2 questions. Find x, give a reason for each stage if you're working out. So you've got your cyclic quad and you've got your arrow theorem. Oh, we want our answer in terms of x, so that's interesting. Right, so BOD is x, so the angle at the circumference is half the angle at the centre. So BAD is equal to half x, right? So what is your reason? Angle at the circumference is half the angle at the centre. Right, so I'm going to label that half x. So what are we looking for? BCD. Okay, so now you've got your cyclic quad, right? Opposite angles in a cyclic quad add to 180. So we know that they would add up to 180. So to get BCD, it's 180 minus half x. And your reason for that one is opposite angles in a cyclic quadrilateral add to 180. Okay, last question, question 18. Right, we have CDE points on a circle centre O. AEB is tangent to the circle. CD equals DE, so it's an isosceles. Angle AEC is X. Find the size of angle OED in terms of X. Give a reason for each stage you're working out. Right, we have the alternate segment theorem. So we've got this angle here from a tangent. We also have the isosceles triangle CDE. So we know these two angles here are the same. So DCE is equal to DEC because it's isosceles. That's given in the diagram though. And they equal 180 minus x over 2. So if we knew the angle x, we take it off 180 and divide by 2. Okay, so we actually want to work out here angle OED, which is this one here. Nope, it's not that angle. OED is this angle here. That's what we're working out. But we know we can work out OEC next because we know OEA is 90 degrees. So OEA, that one, it's a right angle. So OEC is 90 minus x. So now we know that this whole angle here is 180 minus x over 2. And that mini angle there is 90 minus x. So if we subtract the 90 minus x from the 180 minus x over 2, we should get our answer for OED. Running out of space here, but let's actually halve the 180 minus x. It would be 90 minus half x minus 90 plus x, because minus x is plus x, which simplifies 2. Minus half x plus x is just half x. So that is your final answer for OED.